Okay, so we're going to keep going with factoring. But before we get there, let's remember some of the things that we've already done. So if I would like you to factor something like x squared plus 7x plus 10, I don't see a GCF. It's not the difference of perfect squares. This number right here is a 1, which means that I can look for numbers that multiply to 10 and add to 7. And I think that would be 5 and 2. Keep in mind the only way to get x squared is to do x times x, so here is our plus 5 and our plus 2. If I was to do x squared minus 3x minus 40, again I do not see a GCF. It's not the difference of perfect squares, so I'm going to see if there are numbers that multiply to negative 40 that also add to negative 3. And once again, the only way to get x squared is x times x. And numbers that multiply to 40 are 8 and 5, which are 3 apart. So that's a negative 3, so I want that to be negative 8 and positive 5. Okay? If you had x squared plus 5x minus 14, no GCF, not the difference of perfect squares. So this is going to be, again, looking for the multiply add method. And that will be 7 and 2. So x and x give me x squared. And then, let's see, I think I want that to be a positive 7 and a negative 2 so that they add to positive 5. If you look carefully at what this is, every time we're looking for numbers that multiply to the last number, otherwise known as C, and combine to the middle number, known as B. So we're going to call this the add multiply method. Okay? Now, that's review. That's the old stuff. What if I was to give you x to the 4th plus 7x squared plus 10? Can we use the ideas from the top to help us do this? Okay, I want you to think about if we were to double distribute these, you know that this would end up being x squared plus 2x plus 5x minus or plus 10. Okay, and then of course keeping in mind that these two things go together. So why do those go together? They ended up being like terms. And when I multiplied the x times the 2, I got 2x and there's 5x. But when I multiplied x times x, I got x squared. All of those ideas factor into being able to do this. Okay, think about what might be able to get x to the 4th. So I know that x to the 4th is x squared times x squared. So I want to keep that in mind because that right there is an x squared. So it may not look like it at first, but this is really another add multiply method type of problem. What are the numbers that multiply to 10 and add to 7? Well, again, think of 5 and 2. Think of how this trinomial right here is similar to that trinomial. Okay, so I still think that the numbers I want are going to be positive 5 and positive 2, but now how do I get x to the 4th? That will be x squared times x squared. And then this is plus 5 and this is plus 2. Okay, let me show you how that actually works out. If I were to double distribute, x squared times x squared is x to the 4th. There's that. X squared times 2 is 2x squared. 5 times x squared is 5x squared, and then 5 times 2, of course, is 10. Here is your 7x squared. Same idea as the regular add multiply method. What if I were to do x to the 6th minus 3x cubed minus 40? Okay, well again, look at how this is similar to this. I know you've been asking me to number, so here's 1 and here's 2. Okay, I'll put these as A, B, and C. So notice how number 2 is similar to letter B. Okay, the only thing that appears to be different to me is the exponents. So how do I handle that? Well, I think of x to the 6th I know that x to the third times x to the third is x to the sixth, which is a really important idea because that is x to the third. Okay? So I'm going to try and treat this, notice I just used the word try, as multiply add method. Okay? So from the top, I already know the numbers I want are -8 and +5, because -8 times 5 is -40, -8 plus 5 is -3. Well, what would happen if I put x to the third right here? Because I know that x to the third times x to the third is x to the sixth. Okay, so let's try it. If I do x to the third times x to the third, I get x to the sixth. X to the third times 5 is 5x to the third. -8 times x to the third is -8x to the third. And -8 times 5 is -40. Those go together as like terms, so I get -3x to the third. Okay? What about if I were to do x to the 10th plus 5x to the 5th minus 14? Well, again, that seems very similar to letter C above, which means I know that the numbers I want are 7 and -2. Okay, but why can I do that? Why can I use the multiply add method here? Well, x to the 10th is x to the 5th times x to the 5th. So if I were to put x to the 5th in both of these spots, okay, thinking a step ahead, x to the 5th times -2 is -2x to the 5th. This is positive 7x to the 5th. Those are my like terms that are going to combine to 5x to the 5th. Okay, so already I'm noticing a couple of patterns here. What is the relationship between this thing right here and this thing right here? And it's always been true, even in the earlier easy questions. Okay, it looks to me like there is a definite relationship there, which is why I'm able to do this no matter what I'm looking at. So if I had something like x to the 12th plus 13x to the 6th plus 36. It's a very important idea that I see here. Okay, so I think I'm going to treat this the same way I always have. There is no GCF. It's not the difference of perfect squares. The number out front of here is still a 1. So I'm going to try doing this using the multiply add method. Are there numbers that multiply to 36 that also add to 13? I know that 9 times 4 is 36, and I know that 9 plus 4 is 13. So I think I'm going to use 9 and 4, both positive. But notice I didn't put x here and here, because x times x is not x to the 12th. What is? You're probably right. It's x to the 6th times x to the 6th. And what you probably should do is multiply this back out to prove it. Make sure that really is this trinomial. Okay? So, hopefully that's not too entirely foreign for you. So if I were to look at something like, let's see, number 5 will be x to the 20th plus 2x to the 12x to the 10th minus 28. Am I seeing the pattern there? Well, no GCF, not difference of perfect squares. The a value is equal to 1. So can I do the multiply add method? Are there numbers that multiply to -28 that also add to +12? The answer is yes. It is 14 and 2 is 28. So I think this needs to be a +14 and a -2. But what would go here so that I multiply things to get x to the 20th? Now yes, there are lots of different things that could do that, but I have to have them combined to x to the 10th, which means this needs to be x to the 10th and this needs to be x to the 10th. I'm curious as to whether you've figured out the pattern yet. And the way I might ask you that, well, before I get there, let me do one more. What if I were to do x to the fourth minus 9? Okay, is that the difference of perfect squares? Yes, but it's a higher exponent, but does that really change the way we think about it? And it doesn't. Okay, that's a perfect square, that's a perfect square. We're looking at the difference, which means that this is going to factor so that I have positive 3 and negative 3, and then what times itself is x to the fourth? That would be x squared times x squared. Okay? So what ends up happening is students will eventually ask me, can you do something like x to the 10th plus 12x to the 7th minus 28? And that's really what I'd like you to think about and come ready for class on Monday. And then we will practice more of this factoring with higher exponents. All right, have a good weekend. Please make sure you write down any questions you have, or feel free to email me if you would like to. See you Monday.